reading. So we were doing epidemiology. Last class we saw the rate ratio and all, the different types of death rates, the morbidity, incidence, prevalence. And then we went to, what is that? The different types of studies, observational and experimental. We went through this. I told you it is like a blueprint of this whole chapter, what we are doing. It's like a whole blueprint is here. So we did with the, epidemiological classified into observational and experimental, and we were dealing with the descriptive epidemiology. So we did with the study of frequency, under which we studied rate, ratio, proportion. The frequency of disease being explained using the terms incidence and prevalence. And now we are going towards the study of distribution. I think we did time also when we are going to describe how a disease is distributed. We always describe it in three in terms of time, in terms of place, and in terms of person. So we have done not done completely, we have done a part of how we describe a disease in terms of time. So in terms of time, there is three sub-classification: short-term, periodic, and long-term. It is also called as secular trends. And in long-term, remember this term secular trends, because if MCQs are coming, it can give this as an option. The other term, short-term, periodic, you will understand from the terminology itself which duration they are indicating. But when it comes to the secular trends, and if you are not sure, it is the synonym for the long term. From that term, secular, you won't be understanding the duration. So usually MCQ come from here, where the synonyms are not giving you any indication what it is saying about. So in short term, we saw that the main example would be a epidemic disease. And I have seen among you, exactly I don't remember, maybe at least one person, but majority of you, you have made a wrong when the MCQ was asked what is the epidemic disease. I don't know why you made it confused. Maybe before to the exam yesterday, last class I explained you what is actually epidemic. It is excess of a case. So that is the in the MCQ, the question can be altered in whichever way they like. But in that sentence, when you select the option for epidemic condition, there will be the term excess. That terminology excess that you have to find out. Excess or something that is synonym to word excess. That should be there. And in which sentence you get that keyword excess, that is the answer for the epidemic. So epidemic, it always means something that is of having a common clinical features, a common source, but that will be increased or excessively found. And how much excessive, that also I told you in last class, it depends. It can be, if it is a very common disease like influenza or etc., chickenpox, not measles, chickenpox, like common disease, then we can say if it is more than 2 SD. 2 SD is actually a biostatical term that is used. So there will be a common average of mean area. So from the mean, uh, if it is above 2 standard difference above, which means 95 cases may be included in that. So if that's actually a statistical calculation. So from the mean value that should be present in a particular area, if it is more than 2 SD, then it is considered as a epidemiology. Sorry, it is considered as a epidemic disease. Or sometimes, if it is a very rare disease or disease that is not commonly seen, or which has not been seen since years, even one case, appearance of even one case is considered as an epidemic. So it depends. Anyway, the term excessive presence of a disease or a death rate, etc., that word excess should be there. So don't make a confusion again. So in short term, when we say it is the epidemic usually, and we saw that there is common source, propagated, slow epidemic. Common source, a single exposure like a food poisoning when all the persons have the disease in the same incubation period. When we draw a graph, it will be like a single U shaped. It will go up and then come down. There will be single exposure, and multiple exposure means the source will be same, but there will be repeated exposure. And we saw that a contaminated well, river, etc. can be an example for that. Then propagated epidemic for man-to-man propagation or a disease that is spread by some vectors. So that comes under the propagated epidemic. So there will be some initial cases initially, or some index case, what we say, or the primary case. So after to that, there will be a gap period because now the disease have to be spread from one patient to another. It will be spread and there is a need for some incubation period in between for the symptoms to arise in that second group of people. And after to that, after a gap, the second set of people will be developing the disease. So unlike the single exposure, the graph here will be different. It will be different like a W, but the W, the lower portion will not be touching the base. It will be going high, lower, lower, and then it continues like that. Propagation, like a wave, propagated wave it will be. Then slow epidemic, it will be like our chronic diseases because it is also a slowly developing but excessively found and hence considered as an epidemic disease. Then we had to start with the periodic one. So these were the graphs that we saw. Contaminated, propagated. Now periodic fluctuations. So periodic fluctuations will be having a seasonal trend. We know that certain diseases, it is having a seasonal connection. So measles, varicella or the chickenpox, cerebrospinal meningitis, URTI, malaria, etc. All these conditions will be having a seasonal trend. For example, measles is usually seen in spring season, gastrointestinal infections during summer season, and non-infectious diseases. So not only the infectious diseases, but the non-infectious diseases also can show this seasonal trend, like the sunstroke. So definitely during a summer season, hay fever during the spring, and then snake bites. Snake bites also, it can depend upon the climate or the weather. For example, in case of snakes during the breeding season, they will be very aggressive. So they may show this increased snake bite during their breeding season. And if it is the snakes who are in or which are living in a tropical countries, it will be more towards the night time or the colder weather they will be coming out. So because during the heat they don't want to get exposed to the heat. So during the night or the whenever there is a cold weather they comes out. So at that time the snake bite can be increased. So based on these features we can see the infectious, non-infectious disease changing according to the season. Then there is something called a cyclical trend. So not based on season, but some other trend, a cyclical trend we can see in certain diseases. So this will be extending like for short period of time or maybe longer also, maybe days, weeks, months, or even years. And how we say that measles earlier, before to the vaccination, it used to appear every 2 to 3 years. This could be asked as a MCQ. And rubella, which is German measles, it used to appear every 6 to 9 years. So every 2 to 3 years, epidemicity of measles or an increase of measles cases used to appear in the pre-vaccination time. And German measles used to appear every 6 to 9 years, like a cyclical condition. So this was due to variations in herd immunity. A buildup of susceptibles is again required in the herd before there can be another attack. What that means is when the pre-vaccination era means maybe that were vaccine, but it was not fully accepted by the people, or the government had not induced it. Uh, this one, the government induced this vaccination after WHO suggested that in 1970s. I don't exactly remember the year. It was after to 1975. WHO I mean, WHO demanded or requested to the member nations that they should implement the vaccination. So before to that, maybe some people were taking, or may not be, they were taking. So at that time, some people, they might have developed the disease, and then they develop the immunity against that. So that immunity will be given to the next generation, and sometimes they will act as a obstacle so the other people don't get infection so easily. But then when that susceptibles number increases, or the immunity level within the group decreases, it will take some years. So then when that immunity level decreases in a group of people, more number of people who are susceptible to the disease will be increasing. And when that happens, their disease will be reappearing. So this duration was seen in measles and also German measles. It's also this cyclical trend we can see in non-infectious conditions also, like automobile accidents in US are more frequent on weekends, especially Saturday, maybe because of the weekend and the partying nature, and after that drink and drive. So that resulted in the automobile accidents. So here there is a cyclical trend that is happening. Event is repeated in a cycle of days, weeks, or months, but it is not based on the season. A knowledge of cyclicity of disease is useful in that it may enable communities to defend themselves. And even now, in case of this one, influenza, the virus, it is told that the virus which causes influenza, it can undergo variation. We call it as antigenic variations. And every 2 to 3 years, new varieties of influenza virus can be formed due to mutation, and it can result in a epidemicity. So you might have seen, I mean, that portion is coming when I'm going to teach emerging and re-emerging disease, but I just told now to indicate the cyclical trend. So during when COVID was getting spread over here, there was a video coming up um, in the YouTube saying of Bill Gates and also WHO secretary, I think, that they were expecting a pandemic to happen very soon in the world. And this video, it was recorded in somewhere in 2015 and 2016. So people at that time during the COVID time, 2020, 21, they used to say that this pandemic was created or by Bill Gates so that he can flourish his business or whatever. Well, I don't know that much details and all, what exactly political things, but still, they might have told it because of this antigenic variation. This is a characteristic feature of influenza virus. So even though we call it as COVID-19, the coronavirus is basically belonging to the group of influenza type of virus. In that, the mutation happens, and then different varieties comes in that group. That is the MERS, SARS, H1N1, H5N1. All these are basically belonging to the influenza group of virus and then undergoing mutation. So this is a possibility that every 2 to 3 years they can have a antigenic variation, and this variation can happen in 2 to 3 years and also 6 to 9 years. So when it happens in 2 to 3 years, there will be only a slight increase in number of cases, may not just an epidemic, and it can remain as an endemic in a particular area only. But if this antigenicity is happening in a long duration, like in a decade, like taking 10 years, And if that is happening, it usually can result in a pandemic condition. So before to corona, I mean the COVID-19, uh, the variation happened during the 2010s, which was actually resulting in Middle East. It was called as Middle East Respiratory Syndrome, MERS. So it happened at that time, but because it was concentrated only in the Middle East area, and the whole world was not that much bothered about it. But next variation, which happened a decade later, that was in 2020, it became a pandemic. So this is actually a cyclical trend that the influenza virus shows. So we should be expecting the next antigenic variation, the slight variation to happen to the virus in 2 to 3 years. So maybe in 23, 24, now 23 is running to maybe 24, 25. And in next 10 years, a bigger antigenic variation in the influenza virus. So that type of cyclical trend can be seen in organisms. Then long-term or secular trends. So this long-term or secular trends means, as the term indicates, over the years, the changes that occur in the prevalence of the disease over the years. But there is a difference. There can be a progressive increase or decrease. When we are discussing about the earlier division, that is the short-term increase, though we said about slow, what is the exact term? Slow or modern epidemics. So here there was a clear cut they indicating the NCDs, the slow arising epidemic itself. And epidemic means there is excessive cases. But when we come to this term, that is the long term or secular trends, it also indicates disease variation that is happening during a longer duration of time, but here there can be an increase or decrease of disease. So either there will be an increase or the decrease over the years. In case the previous one, it was indicating only there is an increase of disease over the years. But when we are saying about this classification, the long term or the secular trends, it indicates an increase or decrease in the prevalence of the disease over longer period. So the examples include coronary heart disease, lung cancer, diabetes, etc., or obesity, or lifestyle disease, which has shown consistent upward trend in the past 50 years or so and still increasing, followed by a decline in diseases like tuberculosis, typhoid fever, diphtheria, and polio. So I hope you understood the difference. In the previous one, they were saying only about the modern epidemics or the modern lifestyle diseases, which is as like an epidemic increasing in number over a long duration. So that one is mentioning only about an increase in prevalence, so the increase of disease condition. But when we come to the longer one, the long term or the secular trends, it is also duration is mentioning in years, taking a long gap. But here there is not only increase, we mention about those diseases also which are decreasing. So the lifestyle diseases are increasing over here, whereas the tuberculosis, typhoid fever, diphtheria, etc. are decreasing. So both the diseases are included under this classification, the long terms or secular trends. And usually the MCQs based will be coming under this section. So next is the place distribution. Place distribution, we study the distribution of a disease based on the area that is affected. So we can have international variation, national variation, rural, urban, and also local distributions, which means that certain diseases will be more commonly seen in some countries and not that commonly seen in other countries. For example, last class, I think I told you in case of polio is now existing only in Pakistan and Afghanistan, not in any other countries. So when we study about a disease, there is a variation, international variation. And when we go for rabies, is it common in Malaysia? Can I get an answer? Is rabies common in Malaysia? I mean, dog biting. Are you all hearing me? Huh.
I seldom heard about this case, such cases.
Southern part of Malaysia. Okay.
I think there
Uh,
is it's, but not so, maybe not so much.
Okay, so if you're taking this much time to answer, I guess rabies is not that commonly found over here. Probably it is the yeah, dogs are lesser. And then people should either go for a bat infested area to get rabies. So the incidence should be very less when compared. But if you see in India, every day there would be at not one, I don't know. If I take all of India, at least 30 to 40 dog bite cases should be there every day. Because that much common is how many people end with rabies, that is comparatively less because they go take the injection after to that. But the dog biting is very common in India. And when we go to countries where there is ocean or surrounded with ocean, like Australia, New Zealand, they don't have any cases of rabies or even the dog biting. So it is told that in case of rabies, the oceans or water bodies act as a barrier that has been seen as a feature. So, and how these people understood is they studied the epidemiology, and then only they were able to see that the rabies, the cases, it is not less, it is zero actually in cases of those continents which are surrounded with water. So maybe the accessibility is not possible. I don't know what is the reason. But anyway, that such a thing is seen. So many diseases, we can see that there is an international variation. If we take tuberculosis, most of it will be in India and other African countries. So it will be varying. But when we go for neurodegenerative diseases, the stroke or likewise neurodegenerative diseases, we can see the incidence might be more common in well-developed countries like US, etc., but not that much in a poor country. So we can see any disease, there will be some international variation. Similarly, when in the national variations, now that, yeah, the best example now Lenny told, um, the rabies may be there in the south part of Malaysia, but not sure. So which means within the country, some area only, some parts of the country will be affecting that diseases. And this can also we can see in within the small space like Selangor. If we are going to take Selangor and then we are going to compare, there can be difference in rural and urban community. It is not that everyone will be uniformly affected, and then there can be a local difference also. So most of the disease will be showing such a geographical pattern. The third type of distribution will be person distribution. So based on the features of the person, based on his age, sex, occupation, marital status, habit, social class, and other things, the presence or absence of diseases might be there. So starting with age, it is strongly related to disease than any other single host factor. Some diseases will be very common in certain age group. For example, measles. Usually it is very commonly seen in children, cancer in middle age, and atherosclerosis in old age. Sex is another one. And here we use this indices like sex ratio. We saw what is sex ratio, sex specific morbidity and mortality rate. So some of the diseases we learn like which sex is having more predilection to develop the diseases in your PM. And here also we can see some examples like diabetes, hyperthyroidism, and obesity are more common in women than in men. Whereas the diseases such as lung cancer and coronary heart disease are less frequent in women. And one of the important reasons which we can assign would be the substance abuse. Because females generally, less females have the habit of smoking or even alcohol. So that might be the reason. But now, if we take the current researchers and we see that the habit or the addiction to smoking and alcohol is increasing in females also. Likewise, Now we can see that the incidence of lung cancer and CHD is increasing in females. So this scenario, now that we say the example that the lung cancer and coronary heart diseases are less common in females, in coming 10 to 15 years, the scenario might be changed. Like more and more women, if they are going for substance abuse, even they are going to get affected of these diseases. However, we can classify the diseases commonly seen in a particular gender. Then ethnicity, there's also we study some of the disease we say this is very common in particular ethnic people. Marital status, uh, marital status can be a risk factor for some disease and condition. The observation that cancer cervix is rare in nuns led to the hypothesis regarding marital status and cancer cervix. So this might be something that you already know. In case of cancer cervix, this is usually seen in females who bear a lot of number of children, who have multiple sexual partners, and who might have got induced into sexual intercourse at a very young age. So when compared to that, it is usually married women with a lot of children, usually having a tendency to develop cancer cervix. So nuns, they don't have that much incidence of cancer cervix, but they can develop breast cancer. Because breast cancer, one of the important reasons for the development of breast cancer is non-parity. Then even if you're given birth, but if the mother had not breastfed the baby, um, so these two factors, genetic conditions are also there, but other than that, these two factors can result in breast cancers. So in unmarried women, women who have not breastfed their children, they have a more tendency to develop breast cancer, and the vice versa, like the women who have had more children who are married, they have the tendency to develop cancer cervix. So marital status can also influence the appearance or the distribution of diseases. Then occupation, the lot of occupational diseases nowadays. Uh, People who are working in coal mines, they are more likely to suffer from silicosis and other disease conditions. Then based on the social classes, individuals who are in the upper social class have a longer life expectancy, better health and nutritional status than those in the lower social classes. Certain diseases, example all the CHD, hypertension, have shown higher prevalence in upper classes than in the lower classes. Notice this sentence, but when we go later to other slides, you can see some opposite sentences also coming up. However, we'll see that. Then based on the behavior, that's usually their habit, the alcohol, smoking, sedentary life, overeating, drug abuse, it can also affect the incidence of a disease. Uh, I don't know, maybe you probably already know this. If a person have got hypercholesterol, and if he's having high increased cholesterol only and no other risk factors, we need not worry that much about his he ending up with a chronic heart disease. Uh, for example, a person is coming to you who is having high cholesterol, um, maybe 350 or 400. 400 is a bit more. Anyway, 350, we'll stand with that. 350 milligram percentage, that's his cholesterol level. And he is not having any other bad habits like no alcohol, no smoking. He's not that much fan of fried meat or whatever, all those cholesterol things. He's just controlling his diet also. But somehow his cholesterol has been increased like that. But then we go to his family history, and in family history also we don't see any history of CHD over there. Uh, so in that person, we don't have to worry whether he will develop a chronic heart disease. It is very, very, very less. The only thing, we don't even have to interfere with our medications also to reduce this cholesterol. Can just say him to adopt certain exercises or a walking habit, and by diet itself, ask him to reduce that cholesterol. So, but a person in other way around, if he is having only 200 milligram percentage of this cholesterol, and along with that, he has got this habit of smoking, alcohol, or having junk foods, etc., and no exercise or leading a sedentary life, then we need to be very careful. To that person, we have to advise a lot. Maybe even medicines could be given uh, so that he doesn't develop a CHD. So the behavior pattern also decides the end result of particular thing, whether a disease should appear or not just that biochemical value. So in all this distribution, another thing that we have to consider is migration. So in case in India, some diseases like leprosy, filaria, malaria were considered to be a rural problem. When we are saying about the place distribution, we have seen that there will be geographical differences. So in India, it was considered these three diseases belong to a rural population. But because of migration that is now happening, people are migrating to different parts. And now we don't see such a rural and urban population difference because of this migration. So whenever we are going to describe a disease condition based on places, we should be very aware of the rate of migration. Like if you are going to study some disease condition of UK, suppose, uh, the migration, the people coming into UK, that is a factor which couldn't be neglected. Um, and similarly, when we are going to study about some other lower countries, like we are going to study the same condition affecting in people living in Sierra Leone. That is the name of the country, right? Or Senegal, Nigeria, where the migration rate into that country is very less. Uh, they have to consider the people who are going out. So migration is a very important factor which shouldn't be neglected when we are describing a disease based on places. So finally, about the descriptive studies. So the descriptive study, as the name implies, we are describing the distribution of the disease. It can be distribution of disease, injury, or any health-related events, so that we get the burden of the disease. This summarize the patterns of disease in terms of time, place, and person. And usually the descriptive study is based on mortality statistics. That's why I told when we are going to study or start a research question based on tuberculosis, HIV, whatever, we are going to explain about the population, and also we are going to start with the mortality, with the crude death rate, and then going towards the specific death rate, the age specific, the gender specific, like that we have to go. So everything, it starts usually with the mortality statistics, how this disease is affecting. Only the mortality rate gives us the primary clue how much danger this disease is. Otherwise, if a disease is there but it is not causing much mortality, we need not worry about that disease. Like the one we told, the chickenpox, it can increase, but nowadays it is so controlled because of the lifestyle of the people. So even if the people are affected with chickenpox, they are not going to die as they used to be in years before. So there is nothing worth in studying a disease which is not causing much mortality. It's just a waste of time. So we would be, or the epidemiologists would be more interested to study those diseases which are going to cause a higher mortality rate. Because our purpose to study a disease is to find out its causes, its pattern, so that we can introduce some programs to solve this condition. That's the basic principle. So if the disease is not causing any mortality, or there is less mortality, there is no meaning in wasting our money or our time in that type of diseases. So it is usually based on the mortality statistics that descriptive studies comes up. For example, the case fatality of cholera in 1854 in London was 40%. It was studied by John Snow, and only because the case fatality of cholera was 40%, which made him to study why this much number of cases are appearing, in which population, and how it is appearing, so that they could reduce the death rate. Otherwise, there is no meaning in spending time. In descriptive studies, this is another important point, or the most important point. There is no attempt to analyze the links between exposure and effect, which means they are not going to, whenever a disease is coming, there is a reason for that. We always study etiology. The etiology can be a microorganism, as like we learned in the germ theory, or according to what we learned towards the advance, the web modality, or the web of reasons, web of causations, that's the exact term, sorry. So web of causations, there may be a lot of causes, but whichever disease we take, we try to find out its etiology, from where the disease is coming, or the origin of that disease, and then we connect it to the outcome also. But in case when we are doing a descriptive study, we are not going to connect it, the etiology and the outcome, or the exposure and the effect. We are not going to connect, we are just going to observe it. We don't do any analysis. For example, if I could say, in case uh, in case of a descriptive study, when we describe about smoking, we just say there was a increased incidence or a prevalence of lung cancer in smokers. That's only, this is a statement actually. You're coming up with that statement. You took a population and then you did some questioning, interviewing something, and then you reached into conclusion that in smokers, or the people who were you studying, in smokers, the in prevalence of lung cancer was higher. That's all you are going to say. You are not saying, or you are not going to prove whether it's right or wrong. But some research, it can start from that sentence, and they decide to prove whether it is true or not. So descriptive studies, when you explain all these things, the person, place, time, everything, you will end up with a statement. We can call that as a hypothesis, or we call it as an etiological hypothesis. Here, when you say that among the smokers, the rate of lung cancer was higher, it's a kind of statement, but a hypothesis, we could say that you're saying that there is something, or some reason why this cancer is high seen in smokers. And then you stop it over there, that's descriptive disease. And some researcher who was going through this research, they see this statement and they start from the, is it true? Is it true that the lung cancer is more commonly seen in people who are smokers or not? And then they are going to study from the, so if they are going to establish it, they need to prove it by mathematical calculations, and here it will be the statistical calculation that will be done. And then we call it as the second part of the epidemiology, that is analytical epidemiology, where the researcher is going to test that hypothesis. So the difference between descriptive and analytical is, in descriptive statistics, when you describe the disease, you just describe it. You don't do any statistical calculation. You don't compare whether this etiology and the outcome, or the cause or the effect, whether it is connected or not, mathematically related or not, whether there is any statistical relationship or association. You don't do anything, you just describe it. So that what you end with a descriptive study, we call it as a etiological hypothesis. And when someone starts with that etiological hypothesis and decide to test that hypothesis, those studies are called as analytical studies. So in descriptive studies, we are not going to analyze, we are not going to do any biostatistical calculations to see whether the cause and effect is related. That is seen only in case of analytical studies. We go to the different types of analytical studies also. For example, the cohort, the case control. There only the person is going to, or the researcher is going to study whether smoking and lung cancer is associated, and if it is associated, how much it is associated. So that causal relationship we will study only in case of analytical. Here, we don't make any attempt to analyze. We just make a statement. That's it. So the results are used to understand a population health status, generate hypothesis about the cause of disease, or in other words, it generate the etiological hypothesis and inform program planning and evaluation. This generating the hypothesis about the cause of disease, I put like that, or in short word, it will be etiological hypothesis. It's very important because MCQs can be asked like what the end result of a descriptive study is. And the other one can be the main purpose of analytical epidemiology is. So in case of descriptive study, the end result will be etiological hypothesis. And in case of analytical epidemiological study, it will be testing those hypotheses. So for example, the description in 1981 of 4 young men with a previously healthy state. I don't know, when I was editing it, it just edited. So they were previously very healthy people, and they suddenly developed a rare form of pneumonia, which is exactly pneumocystis carinii pneumonia, which is a common, very common opportunistic infection in case of AIDS patients, and also Kaposi sarcoma. So that led to the epidemiological studies, and then the researchers were able to find out a disease called as AIDS was existing. So this was the first clue, or the first conditions that happened that they generated or they came into AIDS. So the type of descriptive studies, we have 3 types of descriptive studies. The first one is case reports or case series. The second one is correlational or ecological studies. And third one is cross-sectional studies. So case reports will be a report of a single case of an unusual disease or association. So for example, if you take some PubMed or anything, you can see a doctor describing one single disease. Even if we take some homeopathy journal also, we can see that a person describing one single disease like PCOS or anything, a headache or whatever. So when we are saying about a disease in a single patient, we call it as a case report. And when we are actually putting it in a journal, it should be usually a very rare disease or some unusual disease. That should be the, we are not going to publish some very common disease. There should be something important in it, then only we are going to publish it. So a case report will be the report of a single patient who is having one disease or an unusual disease or an unusual associated disease or something like that. So that is case report. And if it is like a series, so many reports of one particular disease combined together, it will give rise to case series. So case report is a single case, and case series is actually a description of several similar cases. So in case if you are going to write an article, for example, in homeopathy journal, and you are going to describe about a patient who got cured of one medicine, say for example, acid peptic disease, you have only one patient, one case record, and you are going to mention the medicine, maybe Naxvomica or Pulsatilla, whatever, and you are going to publish because you had the patient, you cured that, and then you are going to publish it in one of the journal. It is actually a case report. But you wait for some time, and then you have a number of cases, a series of cases, and then you publish it together. It becomes a case series, a large number of 7 or 10 cases of APD. Maybe the same medicine, may not be the same medicine, but it is the same disease you are mentioning about. So that becomes a case series. Then there is ecological studies and cross-sectional studies also. Ecological studies, it examines the population or groups as the unit of observation. For detail, in case of ecological studies, let's check. Okay. This ecological study, it is also called as correlational study. Okay. Sometimes to confuse in MCQ, that term can be used. So in ecological study, it is one of the simplest type of epidemiological study, but not as simple as case report or case series. But this is another simple one. And here information is collected not on individuals, but on groups of people. The unit in which measurement is made will be schools, towns, countries, etc. For example, the PPT or the image that is given just underneath, you can see in case of one question, the underlying question, the researcher wants to find out, do smokers have higher death rates from coronary heart disease than non-smokers? Which means he is going to take a group of smokers and if he is going to study that individual person, the study will be different. But in ecological study, we won't go to the individual one because individual one, there can be various type of studies. But in ecological study, that question will be framed in a very different manner. You can see how that question change. In ecological study, it will be, do US states with higher smoking rates have higher death rates from coronary heart disease than states with lower smoking rates? So here you are going to compare two geographical areas, two states, but not the individuals within. So what's the main difference is you can say that that states in which there is a higher smoking rate, they will be having higher coronary heart disease. But we can't apply this uh, information or the result of that study to a individual. Like they may say, according to this statement, the state New York, I don't know. I mean, I don't know which is the state which is having higher smoking rate in US. I'm just saying, for example, New York. They found that New York people will be having a higher rate of smoking though, and hence they say that they have more chances that New York people will be having more chances of developing coronary heart disease. But this result, if we are going to extrapolate to each individual, it is not possible because it is not that everyone in New York have a higher tendency to develop coronary heart disease because not everyone in New York City will be a smoker. But this type of study is there so that this is very easy, as we told, less expense, data very easy to be collected. So such the studies can also be done. But here, what the result we get, we can apply it to the whole group. That's it, not to the individual person. So that is the difference of ecological study and other type of studies in which individual will be the unit of study. So in ecological study, when we take the exposure, that will be per capita average cigarette sales in each state, and outcome will be coronary heart disease mortality rate in each state. So the ecological study, the question has changed like that. The exposure and outcome, everything is coming actually in state or that geographical area or group of people. They are coming like that, not the individual. But when it is an individual study, like the analytical one, if we go regarding even the cross-sectional can come underneath that, or the case study, case control study, or the cohort study, which is actually coming under analytical epidemiology. Here, the exposure will be individual cigarette smoking habits. Outcome will be individual deaths. So, whatever result we are getting over here when doing a case control or a cohort study, we can apply to the individual patients also, individual patients or individual persons. But the final report that we get in ecological study, we can't apply it to individual persons. And what is the benefit of doing ecological? As I told, it is very easy to do, very easy to get the data, very inexpensive also. So that is why ecological study is being done. Sorry, I missed up the descriptive study. It should have come later only. So one of the error that can happen in case of ecological studies or correlational studies is what is called as ecological fallacy. You should remember this term and also what it means. I have already explained what I earlier explained itself is the ecological fallacy. It is an error made in ecological studies when conclusion is made about individuals based on the analysis of a group data. So for example, we are taking a class, a group of students, and we assume when we checked the total IQ as per this example, some of the students were having a high IQ, like 130, 150, etc. So the average IQ will be higher because of this extreme high value. If we take the average IQ of students in that class, it will be higher. It may be around 90, 100, which is very high, not very high, but still high IQ. But in that, and if you are going to assume that all the students in that class is having a average IQ of 90, 100, we are making a wrong assumption because there may be individual students who are having very less IQ. So that is actually ecological fallacy. You can get results very easily, inexpensive, less time required in case of ecological, but we shouldn't apply that result to everyone or every individual involved in that study. This is a group study, this is a group result and should be seen only in a group manner. We can't apply it to the individual. So for other example is, imagine a study of rate of coronary heart disease in the capital city of the world relating the rate of average income. So according, they are going to, a researcher is going to see the connection, whether the rate of coronary artery disease, its existence or prevalence, how it is related to the rate of average income. So you are going to study that how the coronary heart disease and the income rate is associated, and not for individual group. We are going to study that in capital cities. And within the city studies. So capital city. When we say capital city, you understand that area will be more crowded. The more people will be there. It can include migrants also. Then their lifestyle will be so different. So the capital city of any place cannot be compared to the whole country. Like when we take Malaysia, if we are going to do a study of Kuala Lumpur only, we can't apply that result to the whole of Malaysia. There may be some states in Malaysia which is not as advanced as that of Kuala Lumpur. So when we get a study of Kuala Lumpur, we can't say this is the situation of whole Malaysia. That in simple terms, ecological fallacy is that we can't apply it to everyone or every other situation. So anyway, in this study, within the city study, the coronary heart disease is higher in the richer cities than the poor ones. We might predict from such a finding that being rich increases your risk of heart disease. However, in some conditions, yes, it can be seen like that. The people who are very rich, they are having an increased heart disease, but we can't generalize that in every other part of the nation. For example, some industrialized world, the condition is opposite. Like within the cities such as London, Washington, and Stockholm, poor people have higher CHD rates than rich ones because these rich people, though they are rich, they also have access to better lifestyles. Like they may be going for gyms that is more accessible for them, and they may have only organic food. Then what is that? They can go for type of games, and also their lifestyle will be so different that they can avoid these lifestyle diseases by the lifestyle they are practicing. It's not necessary that these people just being rich, you are going to have these diseases. In some countries, we see that association, where the people are rich, they might be having increased CHD, but the condition is reversing. For example, if we actually follow up, we can see that the industrialized countries like US or UK, uh, in the 1930s, 40s, they were actually very poor because of the effect of the second, not very poor, but yeah, they were not as established as like now in those time, 1940s, 50s, etc. Uh, so at that time, the economical condition in UK was so less, but then they, because of their policies, state policies, their condition began to improve. Maybe in 1980s, 90s, there were rich people, and in if we take the demography at that time and the incidence of all these lifestyle diseases, we could see that there was a increase of all the lifestyle diseases, obesity or whatever CHD, stroke, etc., were increased during that time, this 1980s, 90s, etc. But after to that, if we again now if we are going to study the incidence of these diseases in the developed countries, not US especially, UK or maybe, we can see that the incidence of these diseases are decreasing because they are more aware by 90s and 2000s that these diseases are increasing and it's a lifestyle disease and they need to modify their lifestyle practice, and they started doing that, and hence now the incidence of these diseases, when we can see that it's reduced in all these industrialized countries. And now we come to my own country, India, because I know the health status though better than any other country. So when we go to India, we can see that Indians are seeing a increased incidence of NCDs at this post to 2000, because we got our independence in 1947, but the economic condition of the Indians started improving from the 90s maybe. Late 90s when the globalization came, the IT companies started to come. So maybe it was more evident after to 2000. So more people in India became upper middle class, not rich, I can say, upper middle class towards the 2000 in this decade, the past 2 decades. So now, according to the richness is increasing, we can see there is an increase of the because when there is a sudden booming of economic condition, we will be tending to have much richer food in terms of cholesterol or whatever, I mean oily food or anything. So they had a higher incidence. But now that section of people itself, because they increase accessibility to the other knowledge, materials, everything, they know that now this lifestyle is not good, so better go back. So maybe 20 years later, when we take the demography of India at that time, the incidence or the prevalence of this chronic heart disease and other diseases, we may see that the people in India who showed a higher incidence of the diseases, the upper middle class in 2020s, a reduction can be seen in 2040. The cycle that which we saw in case of UK will be seen very soon in coming up decades in other countries. So every country will be passing through this scenario. When they are initially from a poor status, when they go into a somewhat better condition, the incidence will be higher for the all the lifestyle diseases. But because of the increased knowledge and accessibility, they will be still changing. This we can easily understand when we go to the market also. Um, Initially in India, when we go for the current researches, we can see different types of results. So in India, we can see another result also that nowadays the CHD is being increased in poor people. And it is not that the poor people is having more access to the junk foods or all those things. But if we go to India, these junk foods become a cheaper means of food. For example, if you go to the streets of India, you can get fried items like a snack, and you really have to pay very less amount, like in 1 to 2 ringgits. You can get a full meal that can reduce your appetite. But if you are going for a better option like a organic food or buy an organic vegetable, this is not accessible for many of the poor people in India. So in 1 to 2 ringgits, when they can get a full meal, which is not healthy also, this fried snack will be the oil used in it, maybe even 2 to 3 days older. They will be using and reusing and reusing. That's how the price is reduced. But for the poor people, they have to spend only 1 or 2 ringgits and they get a full meal. They don't bother about the nutritional value of that food, and hence they are having highest incidence of chronic diseases nowadays in India. So we can see that trend is changing. So we can never, the net result is we can never apply or generalize the thing. When a study is made in a group, that is to be applied only in the same group, not to the every individual over there. So ecological fallacy is usually interpreted as a major weakness or a major disadvantage of ecological study or correlational study. However, this ecological study is important because it helps us to enable certain rules and regulations that can act on whole populations. The last type of study in case of descriptive will be the cross-sectional study. The cross-sectional study is also called as prevalence study. Cross-sectional study is, this is the most commonly done study. Out of all the studies, I think all the studies I have kept over here. Yeah. This is actually the hierarchy, we can say, of all the study designs. We are actually coming each one by one. So we saw that in case of descriptive epidemiology, the case reports, the single case, then case series, and then the ecological studies. So we will be climbing up, we will be going through all these studies, and this is actually the weight of evidence. And the first three, it belongs to the descriptive epidemiology, and above it will go towards the analytical epidemiology. And this one, the randomized studies, the clinical study, it will go to the experimental epidemiology. But here also some analytical studies is being done, analysis is being done. So anyway, so we are going towards the cross-sectional study. So when we, this hierarchy is also very important. When we are saying about the research studies, it is always ideal to, I mean, always ideal to do the topmost one, the gold standard, that is the RCT, but it is not always possible. So when we are going to learn something or when we do the article study or something, we need to be very sure where we are taking the information from. Because the information that is coming from case report, case series, or that we are taking from news, the paper, paper means the newspaper, everything that has got a lower value, the editorials, etc. And as the study is advancing, so does the weight of evidence. So now the fourth one is what we are studying, the cross-sectional studies. So in case of cross-sectional studies, this is another easier one to conduct. And unlike the ecological study, though in cross-sectional study, we are studying a group of people. We are studying a group of people in cross-sectional also, but we study it in such a manner the result we get, we can apply it to individual unit. So that is why the cross-sectional study is placed in a higher level than that of the ecological. So the basic unit of study in case of ecological studies will be population, but in case of cross-sectional study, the basic unit will be individual. Means the result what we get in cross-sectional, we can apply to the individuals also. That's the difference. So when we do a PhD or a research study we have to do, or you decide to do a you decide to do a research article something, and you were asked to do a research proposal or research study whatever, and you have to submit it in 1 or 2 months. The easiest one to do is a cross-sectional study. You just get into the population, you decide a population, and then you give a questionnaire and you take information from them. And based on that information, you write a report. And that is actually a cross-sectional study. So if you are going to study about a disease condition or any event, uh, the number you get, that will be giving a prevalence. For example, you are going to study the um, you're going to study about child abuse in migrants in Malaysia. Okay, and you selected a population. Maybe your population was like few people. I mean, that population, you can decide uh, in whichever basis you want to. You have to refer the articles and then decide which population you have to select. Anyway, it is not possible to study the whole of Malaysian population. So then you will be reducing that to sample, and there will be a sample number. This all will come under biostatistics. But there is a formula that is used to find out the sample number, etc. Let that be the anyway. From the whole population, you decided from here you will be taking this much people from that part, south part of Malaysia, north part of Malaysia, west part of Malaysia, central part of Malaysia, and you have decided from take here the some number of people. I mean the migrants, whichever part. So after to that, you are going to study. You are going to study means you are going to go to that people. You are either going to interview them, a group of them, or you may conduct individual interview, or you may just give them a questionnaire which you have prepared, because not every people will be having time to sit and talk. So you just go to one of the school or some area where the people are aggregated, and then you give the questionnaire. This type we can see in certain daily, not daily, monthly books and all. They will be making sometimes article on what is the current population or the current young generation thinking about some condition, unemployment or something. So that's a one-time study. You go into a group of people, a population, and then you give the questionnaire, and each person is going to answer that questionnaire and then return to you, and you get the result. Maybe 1,000 people you give, not all 1,000 might have replied, but just assume all the 1,000 replied, that you assume, and then you are going to make a report. So you don't know anything that happened before, you don't know anything that happened after to that. At that particular moment, what is happening, that you get to know. So when you are studying, now we go to the previous example itself, when you are going to study the child abuse in migrant society, I'm very sure we are not going to get correct data in this matter. There will be some discrepancy for sure. There will be though, but anyway, when you give the questionnaire, one of the questionnaire will be: Are you or were you exposed to abuse, sexual, physical, or mental, or whatever, when you were child in between this particular age? So you're going to get an answer either yes or no, or sometimes people may prefer not to answer. That's why, because the question is so sensitive, we may not be getting such an answer correctly over there. But still, there may be some yes, some no, etc. And then there will be questions further. If it is yes, you will be giving some questions further. And if it is no, then you will be jumping in the questionnaire to some other set of questions. But anyway, your first question is like, not first question, one of the question is, have you been exposed? So the number of people who are answering yes to that, it gives the prevalence. So when finally you get the report, you go through that. Suppose we'll reduce the number now. Just suppose that you are getting only 100, and 40 of those answer sheets, it gave the answer yes and 60 no, which means whether it is true or not, it is indicating the prevalence of child abuse to be 40%. So whenever we do a cross-sectional study regarding any topic, it can be whatever. Now I told you child abuse, it can be tuberculosis, HIV, or same examples, COVID-19, or road traffic accidents, anything you're going to learn, even domestic violence. Um, uh, Anything you're going to learn, because one of the question will be, are you exposed? Because you need to go further questions based on that single question, whether you are exposed or not, whether you are a victim or not. So that question will give you a number. That number is actually the prevalence. How many cases of child abuse is existing? Uh, that gives the prevalence. So cross-sectional study, another name for that cross-sectional study is prevalence study. And why we call it as prevalence study is when we do a cross-sectional study, when we go into a group of people, ask them a question, give them a questionnaire, ask them a question, or even if you're going to learn about smoking in adolescent people. It can be boys or girls, or if you want to just confine within boys, your adolescent boys, however you uh, formulate your question. So one of the question will be, are you a smoker? Because if you don't ask that question, you can't go further. And then the person is going to answer whether yes or not. Then the question can be like, when did you initially started smoking, or how did you start? Who initiated to smoking? The questions will go like that. But the first of the question should be whether you are a smoker or whatever you're studying, whether they have been exposed or not. And the final result, you will get the prevalence. So that is why cross-sectional study is also called as prevalence study. So remember, correlational study is ecological study and cross-sectional study is prevalence study. Likewise, all the studies that we are going to learn now, cohort study, case control study, everything has got synonyms. So you should be knowing its synonyms also, because in epidemiology, the way the MCQs are formulated will be using the synonyms. So if you don't know the synonyms, that can create a complication, like what might be the answer. So cross-sectional study is a type of observational study design. Here, the investigator measures the outcome and exposure at the same time. Like you are not watching for some time. What is this seeing at the same time and following it up? We will study when we are going for, when we go to the next slides and other type of studies. So here they are going, it's a one-time study only. You go to the population, you take the result, and then you're, you take that questionnaire from them, the answered one, and then you're writing a report. After 1 month or 1 year, there may be changes that might have happened in that population. The child abuse, it can be increasing after next year. It was, when you studied, it was 40%. After 2 or 5 years later, when the rate of migrants increase, the rate of child abuse may also have increased, like 50%. But you don't know that. So here, in case of cross-section, we are not following it up. It's just one-time study. You don't bother what is happening before to that. You don't bother what is happening after to that. Just that per time you are studying. So that is why it is called as a one-time study. And here the people are selected just on based on inclusion and exclusion criteria. You will be setting up some criteria, which age group should be included, which sex should be included, whether their educational status or marital status have to be considered. It depends upon what you're studying. And then you have a set inclusion criteria, and then you will be having exclusion criteria. This type of people shouldn't be included in my study. So when you are studying about a migrant, the child abuse in migrant, there is no, your one of the exclusion criteria will be the local people will not be studied. I mean, when you say inclusion criteria is migrants, obviously you're going to exclude all the people who are not migrants. So it is based on that inclusion and exclusion criteria, you select the people for the study. And now when we go to the further studies, you'll see that the people, how we select for the study is different. I mean, there will be inclusion and exclusion, but that will be a kind of different one. So in cross-sectional, it will be population-based survey, as I told you, and it will give us the prevalence of anything, the disease, outcome, exposure, or whatever we are studying. This will be useful for designing the cohort study. One of the study that is coming up, we can understand the situation, and this will act as a baseline in a cohort study. Like you are getting the prevalence of you studied diabetes mellitus, for example. You want to learn about diabetes mellitus in a particular population. You went to a population and you studied about them and how many people are having diabetes, etc., etc. and then you got the prevalence. And when if that prevalence, you make that a total prevalence, you can also calculate the prevalence according to the age group and according to the gender. You can do that calculations. So when you do that, you see that diabetes mellitus is more commonly seen in a particular age group, maybe above 40 years or 50 years. So then you want to study like how these people develop diabetes mellitus. So that can be a cohort study, because you are going to study whether this diabetes mellitus is seen in old age people, like not old age, middle age, 50 plus. It is a common thing, or it happened only in that particular population. And if it is a common thing, that is a generalized thing, why it is happening. So that's like a cohort study. So that cohort study, that idea you got from a cross-sectional study. And this idea, not just a cohort study, you can do further studies, or even a RCT based on this cross-sectional study. The cross-sectional study it can be conducted relatively faster. Obviously, you just need to go one time only, and is inexpensive. However, since this is a one-time measurement, it is difficult to derive causal relationship. This causal relationship we will get only when we are doing cohort study or when we are doing a case control study. We won't get it in a one-time study. We just get what is the current situation now. That's it. We won't get whether this exposure and outcome is connected. We will never get to know. And from this study, we can also calculate the odds ratio. Odds ratio is how much increased risk or you have to develop that particular condition, that we can get to know from odds ratio. So when to use a cross-sectional design? When you want to examine the prevalence of a population at a particular time, we can use a cross-sectional study. For example, you want to know how many families with children in New York City are currently low income, so that you can estimate how much money is required to fund a free lunch program in public school. Because all you need to know is the current number of low income family. A cross-sectional study should provide you with all the data you require. If we change the question, it can be like, um, you want to fund a simple thing. You might have seen that very simple thing. It can't be even called as a cross-sectional design, but a type of a rudimentary type, like you people are having a students activity coming up on 29th, right? And suppose one of you, I'm just saying an example, one of you decided to contribute something like food. It's actually a potluck over there. So one of you decided to bring some item. So you need to know how many people are attending. So that particular moment, that number, single thing you want to do, you can do. When we apply that to a research study like this one, or you can decide to do some kind of activity or some donations like this, or you want to introduce a class. For for people who are smoking in our college, like uh, the smokers, you want to do a program to end or to reduce smoking among the students of LUC. So you need to make a budget. You need to decide how many classes has to be conducted, what has to be done, and of course, these classes or intervention, what you are going to do, it will be including some of the activity, and then you need to make a budget. So initially, you need to know actually how many people will be attending this, and for that, you need to know how many people are actually smokers. So for those things, we need the prevalence, and for that, we use the cross-sectional designs. Sometimes a cross-sectional study is best choice for practical reason. For instance, if you have time or money, not that much time or money, then better go for that. Or if the only data you can find to answer your research question was gathered at a single point in time. And this is usually that is the study done in case of PhD. Because in case of PhD, though they say it is 3 years and it can be extended to 5 years or sometimes 7 years, sometimes even more than that, depends upon the university. Still, everyone who get into PhD will be like to submit the thesis as soon as possible. So if they are going to study some diseases like, I mean, when we go to the case control and cohort, you will understand. Even case control won't take much time, but in case of cohort, it is a follow-up study. You're going to like, you want to prove whether lung cancer is actually seen in actually seen in smokers. So in cohort study, what they do is they take a group of smokers and then they will watch whether they are going to develop cancer or not. So that is a long year process. It will take long years for the smoker at 20 years to develop lung cancer, maybe in his 40s, 50s, or even 60s. So that much is called as a cohort study. And this much time no a person will be having. So for a PhD, when you're going to submit some article or a PhD thing, what you're going to do is always a cross-sectional study and then something based on it, or maximum a case control study, but never a cohort because it is going to take a long time. So that is why cross-sectional study is considered actually as a valid study also, because we get the value prevalence, and we consider this as top than that of the ecological studies, because here we can apply the result to individual persons, because the answer you got, the questionnaire answer you got it of single person. When you gave that questionnaire, you gave to single person. You studied a group of people, yes, 100, but not like 100 were studied together. Like you gave the questionnaire and 100 people gave you the answer. So you have the report of each individual person, which means your unit of study was actually a single person. So the result you get, it can be applied to a single person. So that is why the cross-sectional is compared to be superior than that of the ecological. And in most of the PhD, they will be doing a cross-sectional study where it is mentioned that a survey was done. The survey was done, it indicates a cross-sectional design. So the cross-sectional studies are cheaper and less time consuming because we get the data in a very less time. Then there is something called as longitudinal studies. So opposite of cross-sectional study is a longitudinal study. In case of cross-sectional study, you can see from the picture itself, you are going to study a group of people at a single point of time. You are not bothered about what happened before to it, not what happened after to it. But in case of longitudinal study, you are studying the same subjects, same group of people. That's why the population is having the same color, and you're studying them repeatedly. So this month you went, you studied their collection or you collected their data, and after some time you are again going to them and then collecting the data, and then you are again going. So this will be a longitudinal study. Almost this is the same study design of that of a cohort study. But cohort study will be like for a longer year duration. This follow up, even if you are doing it only for 1 month, 2 months, then it comes under longitudinal study. Anyway, here the data will be collected repeatedly over the time. So that is the difference between cross-sectional and longitudinal studies. And when we compare both of this, longitudinal is obviously better because we are getting more valid data. When we are getting one data from one day, and if it is established by another data also, it shows the genuinity or the validity of our studies. So obviously longitudinal study is better, but to do this, obviously we need that much time, that much resource, money, time, etc. So this is going to be too exhaustive, though the genuinity increases. This is an example to show. You can read by yourself. That's with the cross-sectional and longitudinal. And before to the chart once again. So once again, if we go, we can see that we have completed all these section, and When we go, there is, I mean, I was so confused, should I change this picture or not? But then I decided I will keep it off and then say you the differences from this. So now what we study is ecological study and cross-sectional study actually comes under descriptive epidemiology. That is what we studied. Case report and case series is also the person. I mean, I got it from internet. The person who drew this, though it is very nicely arranged, 90% it's correct. Some changes should be there. One thing, the case report and case series, it should have been in descriptive epidemiology, which is not explained over here. That is the. And in analytical epidemiology, the person who created this, they have kept ecological and cross-sectional also. And this is a bit confusing thing because if we Google it in different websites, in different textbooks, we can see uh, the authors have confused with this classification. Uh, some of the books we can see all these four studies: ecological, cross-sectional, case control, and cohort study. All these in some of the books websites we can see they're classified under analytical epidemiology, but in some books, we can see the first two, ecological and cross-sectional, classified under descriptive epidemiology, and only case control and cohort study comes under analytical epidemiology. So I don't know in which category I should put because whichever I select, I see genuinity. I mean, the website or the textbooks that which says they put the classification like that itself. I mean, so confusing. I'm not yet to say, but I could say one thing because in India we do have a lot of competitive exams. So in competitive exams, if the question is asked like case control or the example for an analytical epidemiology, the answer will be case control or cohort study. Only these two are considered under analytical epidemiology according to the competitive exam because there should be only one answer. And usually it is the case control and cohort study that is classified under analytical epidemiology. Ecological and cross-sectional will come under descriptive. Still, the catch is not yet finished. The point is the cross-sectional. Ecological is pakka descriptive epidemiology itself, no change in it. It is a descriptive epidemiology, but cross-sectional can be descriptive and also analytical. And how that difference comes is whether there is a comparative group or not. The cross-sectional, now the example I told you is you're going into a single population and then you're studying, that is the cross-sectional. Similarly, when you're doing a cross-sectional of a population in Malaysia and you decided to do a comparative study in which you're going to study a population in Indonesia for your PhD or whatever, then you are going to compare two populations. Of course, you studied only one time, so that makes a cross-sectional study. But here you are going to compare two population. And if that cross-sectional study is having such a comparative group, it comes under analytical epidemiology. And if there is no comparative group, even the cross-sectional study will go under descriptive epidemiology. So such a catch is there over there. And because of that, I didn't want to change or tamper this thing, and it was also showing the complete blueprint of the other things. Only confusion was here, and I hope you remembered this. So the thing is, under analytical epidemiology, technically, case control and cohort study should be the only answers, the test or the studies coming under analytical epidemiology. However, cross-sectional can also be included in analytical epidemiology if a comparator group is used. Because in analytical epidemiology, there should be a comparator group. That is the one criteria to do the analytical epidemiology. So when we go to the case control study design or we go to the cohort study, we see that there is a comparator group. So the studies which have got a comparator group, it will be classified under analytical epidemiology. So in that manner, ecological study or correlational study is forever, no confusion, it is coming under descriptive epidemiology. The confusion always comes because of the cross-sectional study. And cross-sectional study, if there is a comparator group, it will be coming under analytical epidemiology. And if there is no comparator group, it will be going towards the descriptive epidemiology. So we have done up to that. And in the next class, we have to do the cohort and the case control study. Yeah, so now we go to this flow chart, that which I didn't explain last class. You can see the researcher have assigned the exposures, or he decided to learn about the exposure and the outcome, the causal relationship. So if he had not done, he is not interfering, that will become an observational study. And observational study, again, the next question in the flow chart will be whether there is a comparison group. And if there is no comparison group, it will be a descriptive study. And yeah, even the ecological study, if the ecological study, they are going to compare two population, then also it will go towards the analytical study. But ecological study can be done of a single population. So that is why the confusion we see in different websites, in different textbooks, whether the ecological study or the cross-sectional study should come under analytical or descriptive. So always keep in this point that whether there is a comparative group or not. And whenever the MCQ is coming, for your safe position, and mostly the question person who is going to put the question, they will also not be putting you in much confusion. It will be only in the options. Other answers might be there, the options might be there, but the answer in case of analytical, which is an analytical study, the option will be either case control or cohort. Or if they are giving, they should be giving it as cross-sectional with a comparative group. Otherwise, if it is a competitive exam in India, they have to cancel that question because it's so confusing. So it depends upon whether there is a comparison group or not. If there is no comparison group, in case of cohort and case control, then there is a need. I mean, they can't do that study without a comparative group. So there is no doubt in that it is coming under analytical study. But the ecological study and the cross-sectional can be done without a comparative group. So that is why those two studies comes under confusion in which category it has to be put. And the only condition that you have to remember, if there is a comparator, then it goes under analytical study. And if there is no comparator, it goes under the descriptive study. So that is why if there is a comparison group, they have classified, yes, means analytical study. And analytical study, they have put the case control, the cross-sectional and cohort study. And if there is no comparison, it is going towards the descriptive study. Okay. In the cross-sectional design, that is what the cross-sectional studies can be used for both analytical and descriptive purposes. And in the case of analytical studies, they try to answer how or why a certain outcome might occur. And in descriptive, it says only about the outcome. They are not studying about the exposure and they are not doing any comparison also. And the advantages of descriptive study, it is very quick, easy, and cheap. And it helps in formulating etiological hypothesis. And the limitation is that it is limited to describe the occurrence of a disease in a population. We are not comparing with other population or something. It's simply about that population. It is unable to test the hypothesis. When we say lung cancer or lung cancer is usually seen in smokers, when we say that, it is only descriptive. When we are going to test it, then only it becomes analytical. So testing of hypothesis is not done in descriptive studies. Weakness of case reports and case series are that they have no comparison or control group. They cannot be tested for statistical association, and they are especially prone to publication bias, especially where case reports and series describe the effectiveness of intervention. This should exactly go the limitations. When I send you, I will change that position also. So this will become the limitations of the case reports and case series, that there is no comparison group over there. And hence we can't do any statistical comparison or calculation. And because if we want to do a publication, we may manipulate the result also. No one is waiting to know. So there can be a publication bias also to describe the effectiveness of a particular intervention. And that is why, because of the bias is more, in the hierarchy, case reports and case series are placed in a lower position. Okay, analytical epidemiology we'll do in the next class. So technically, as I told, that case control and cohort, only these two studies comes under analytical epidemiology. Can someone take a I mean, a screenshot? It has been taken or already taken?
Okay, try take now.
Oh, you want me to stop the? You should make me remember. Focus content.
Recording. You all want to on the camera.